Welcome all of you. Today we are going to study about the constant which is called pi. Now you all have heard about the pi. Pi is a constant which is generally used in finding the area of a triangle. It is also used in sphere. We use in finding the perimeter of a circle, volume of a cone, then volume of a cylinder, volume of a sphere. So what we see that this pi is generally used in all those object, three-dimensional or two-dimensional, which are circular in nature, that is which are spherical or circular, whether it circular. All the names which I have taken right now, all those names are those names which have a circular portion or which are circle or spherical. So today we will discuss about how this pi has been discovered. From where did we get this pi? Now we know all these formulas and we accept it without going or without talking much about these formulas, how these formulas have been derived, or from where did we get this pi. So what is this constant? How did we get this constant pi? So we will just see here what is this pi. Now the symbol of pi you all know very well. The symbol of pi is this. This is the symbol of pi. It's a Greek, this is pi, and it is a Greek letter. This pi is named after a Greek, you can say a mathematicians. Now we will discuss about, for discussing pi, since right now we said that the spherical or the circular portion is related to this pi, means this pi origin is from the circular object, spherical object, two-dimensional or three-dimensional. So what we are taking here, we have taken the circles we have taken of different sizes. You can see these all circles are of different sizes. Now what we are going to do, we will measure the perimeter, this outer boundary of these circles. We measure of all the circles, assuming that we don't know 2 pi r, because we assume that the pi is not has not been discovered till now, and we are finding out the perimeter of a circle manually. How can we do? We can find out with the help of a tape, measuring tape, or with the help of a thread. It won't be accurate but approximate. So this way we are finding the perimeter of the circle. Now suppose this perimeter of this bigger circle is a, and also we find out the diameter, and the diameter we measure here, suppose it is d1. Now suppose here also we find out the perimeter. We measure the circular portion, and the diameter we find out, measure, and we write it here d2. Similarly in this case also, the perimeter and the diameter we measure and we write it here d3, and so on. This also d, and this is d4. So what we have done, we have taken a circle of different sizes, and we measure the curved portion, the round portion of the circle, and we have named with the different alphabets to identify the different perimeter of the circles. Now similarly we have also written the diameter. We have denoted the diameter of the 4 circles with d1, d2, d3 and d4. Now what we are going to do, we are finding the ratio a upon d1. Here also we are finding b upon d2. Here the ratio comes out to be c upon d3, and here d upon d4. Now all these ratios, what we are doing, we are dividing all these, and what we see that all these answers, the results came out to be same, to our surprise. Now since when we saw these circles of different sizes, then we must have thought since this is the bigger, so the result would be bigger. This is the smallest circle, so the result of the ratio would be smaller, and the answer would be smaller, means before knowing the fact. But what we saw ki all the ratios are constant, and what more surprising is that and all these constant is equal to pi. The value came out to be 22 upon 7 or 3.14. So it means that if we take circles of different sizes, then no matters what is the size of a circle, what is the size of a sphere, when we divide the circumference or the perimeter of that circular object to the diameter, then that ratio will always be same. And that same, always the constant which we are getting by dividing the perimeter and the diameter, that constant is only known as pi. Okay, so now we can, in short, what we can write here. Now when we saw this fact, we can write here perimeter in, now summarize all, perimeter of a circle divided by diameter of a circle, that is equals to constant, and that constant value is 22 upon 7, now or equals to pi. Now this perimeter which we see here, perimeter in case of a circle, this perimeter is named as circumference. And this diameter is radius plus radius, means r plus r. Now this again can be written as c upon r plus r is 2r. Now this perimeter and diameter ratio is called constant, and which is called pi, which we have right now proved. So from here only we got the circumference formula, that is c equals to 2 pi r. So this way we discovered the perimeter of a circle, which we say in case of a circle the same perimeter is called circumference of a circle. It's the another name, just not it in perimeter of a rectangle, perimeter of a square. Similarly we say, don't say perimeter in case of a circle, we say circumference of a circle. So from this we discovered this basic formula of the perimeter of a circle or the circumference of a circle, that is c equals to 2 pi r. I hope it's very clear. If you have got any doubt, you can ask me and we will discuss your doubts. Just see the steps. We have taken the circles of different sizes, then we measure the circumference, the outer perimeter of a circle, and we divided it by the respective diameter of the circle. Now after dividing the perimeter to the respective diameter, what we found here, that all the ratios came out to be same, and this same value is equals to 22 upon 7, that is pi or 3.14. So from this we can summarize as all the circumference, we have written perimeter of a circle divided by diameter of a circle equals to constant pi. Now more we can write in terms of a circle language. Perimeter we have written circumference r plus r, that is diameter equals to 2r, c upon 2r equals to pi, and from here we got the formula c equals to 2 pi r. I hope it's very clear. If you have got any doubt, be free and do ask me your queries and the doubts. Okay, thank you.